Hello everyone, thank you for tuning in to our video on topic 7.3 and 7.4, which basically is slope fields. Later on in this unit, we'll learn how to solve differential equations analytically, but that is something that's usually not super easy and can even be impossible. A graphical approach to solving these is by creating a slope field, which will show the general shape of all solutions to one differential equation. So let's start by considering a differential equation y prime equals f of xy in terms of x and y. For every point xy in this domain, y prime determines the slope of the solution function at that point. We're going to draw a very short little line segment with the slope indicated at each point on y prime, or the slope field. It will show the general shape of all the solution functions of that differential equation. What does that mean? Let's take a look. Here we have a differential equation. dy dx equals negative x over 2y. Okay, or it might be more beneficial to think of it like this. Negative x over 2y, or x over negative 2y. They all mean the same thing, but usually putting that negative with either the numerator or the denominator can make it a little bit easier to think of. So I'm going to stick with the numerator for now. Part A says sketch a slope field of the differential equation on a coordinate plane. Okay, so what we're going to do is, you see there's 25 points lined up here. What we're going to do is we're going to put those points into this equation one at a time. Whatever number we get back, we're going to draw a very short little line segment with that slope. Let's start with the easiest possibilities. Anywhere where x is equal to 0, this would be 0. So when x equals 0, all of my slopes would be 0. So I'm going to draw a little line segment with slope of 0. I'm not going to do 0, 0 because, as you can see, that would be 0 over 0, which doesn't exist, so nothing exists there. All right. However, anywhere where y is 0, we would have an undefined slope. So when y is 0, we have an undefined slope, except again 0, 0, because that point does not exist. Now we have 16 points remaining. Let's just go through those one at a time, put x and y in, and see. For example, this one right here is 1, 1, right? So if you put 1, 1 in there, dy dx at 1, 1, you would get negative 1 over 2 times 1, or negative 1/2. So what we're going to do is we're going to draw a little line segment with slope negative 1/2, just like that. And we're going to do that again for 15 more points until we see what this shape will look like. Now I can tell you, every point that's like 1, 1, so negative 1, 1, negative 1, negative 1, and 1, negative 1, they're all going to have a slope of 1/2. You can tell by looking at this, or negative 1/2. So those four are going to look like that. Now let's go to 1, 2. So dy dx at 1, 2 would be negative 1 over 2 times 2, or 4, so negative 1/4. Okay, so that is something like that. And again, these points are all going to be similar to those slopes of negative 1/4 or positive 1/4. Now let's try 2, 2. dy dx at 2, 2 would be negative 2 over 4, or also negative 1/2. So these should match the ones we had at 1, 1. And then finally 2, 1. So dy dx at 2, 1 would be negative 1 over 2 times, negative 2 over 2 times 1, or negative 1. So this slope should be negative 1, positive 1, negative 1, positive 1. And our slope field looks like that. Part B says sketch a possible solution curve to the differential equation that passes through 0, 1 on the coordinate plane. All right, so they give us 1 point of 0, 1, and and they want us to draw a solution curve that would pass through that. All right, it should look something like that. And this is in no way, shape, or form the perfect correct answer, but it should look something like that. Okay? So, a lot of times on the AP test, you'll be asked a question very similar to this. You're going to see question A being to draw the slope field. Usually they won't give you 25 points, so it'll be like 6 or 8 points. And then question B will ask to draw one particular solution curve at that point. Okay? Example 2, shown to the right is a slope field for which of the following differential equations? All right, so to do this, the best thing to do, in my opinion, is just to pick a random point that's on our plane here and find a slope there and see which one matches up to it. Okay? So let's try 6, 6. I'm just picking that point. So 6, 6, it's right there. So for 6, 6, so for the first one would be 12. Well, the second one, this is supposed to be a x minus y. So that would be 0. Negative x plus y would also be 0. And x squared minus y would be 36 minus y, or 30. Of course, I plotted 6, 6 in the wrong spot. 6, 6 would be up here. All right, so the slope at 6, 6, that looks to be like it's 0. I'm not sure that it's 0, but it's either 0 or it's really close to 0. So it's definitely not 12, and it's definitely not 30. So it's definitely not A, and it's definitely not D. So it could be B or C. All right, let's just pick another point then and see if we can figure out a different number here. How about 6, negative 6? That point I originally had plotted in there. So 6, negative 6, this would be 0. Oh, we don't have to do that one because you know that's wrong. But for B, 6 minus negative 6 would be 12. And for C, negative 6 minus 6 would be negative 12. All right, this slope looks, it's definitely negative. It's negative something. So I'm guessing it's negative 12, which means C must be our correct answer. Okay, if those matched up again for 6, negative 6s, then just pick another point. And just keep picking points until you know which one it is. Example 3, the graph to the right shows the slope field for the function y equals f of x. The initial condition is 0, 6. What is the range of the solution curve? Okay. Plot the point 0, 6. And draw in what the solution would look like through that curve. The initial condition is 0, 6. So, and it says for x is greater than 0. So don't draw to the left over here. We're just going to the right. X equals 0. So it should probably look something like this. So what is the range? Well, it never hits 4. The highest one is 6. So our range would be 4 to 6. Or 4 to 6. Depending on how you want to write that. Including 6, but not including 4. Example 4. What is the general solution to the differential equation that generated the slope field to the right? So basically, which of these 5 equations would give you this slope field? Well, let's draw an initial condition that goes through 0, 0 here. Probably looks something like that. Something like that. I didn't do a great job of following those, but you get the picture. Let's try that again. That's better. That's better. Okay. So it goes through 0, 0, and then goes up, and then goes down, and then goes up, and then down. But if it goes through 0, 0, we know it's going to be a sine wave. So it's going to be D or E. And since the wave goes up first instead of down first, it's a positive sine wave. So that would be E. Last one, example 5. Consider the differential equation dy dx equals x squared times y minus 1. Describe all points in the xy plane for which the slopes are positive. So we want to know, when will dy dx be positive? In other words, when will x squared times y minus 1 be positive? X squared is always positive. So we just want, when will y minus 1 be positive? Y minus 1 will be positive when y is greater than 1. So to describe all the points, we're going to write out a little sentence here. The points where, well, of course, x can't be 0, because if it was 0, then that slope would be 0. So the points where x is not 0 and y is, sorry, it's supposed to be greater than 1 there. Y is greater than 1 will yield positive slopes. Anything else would give us either a 0 slope or a negative slope. All right, that is it for our lesson today on topics 7.3 and 7.4. Thank you very much for watching the video today.